Welcome to Brain Vision.
All right, today we'll be continuing our discussion of probability distributions. Before we look at our example, I just want to remind us of the definition of probability distribution, which is a table or an equation that links each outcome of a statistical experiment with its probability of occurrence. And we have to remember our two rules for probability distribution. First of which is that all probabilities in the probability distribution must be between 0 and 1, and that the sum of all probabilities in the distribution must equal 1. Now, the example we will be looking at today to determine if this distribution is a probability distribution or not is as follows. It is our x and our p of x there we go. And we have our x values of 15, 16, 20, and 25, and our probabilities of 0.2, 0.5, and 0.7, and negative 0.8. Now, just from drawing that out, we can immediately see why one of the reasons why this cannot possibly be a probability distribution. It's just distribution. And the reason for that is, as we can see in our first rule, all probabilities in the probability distribution must be between 0 and 1. And we have a negative 0.8 here, which falls outside of those parameters. Now let's ignore that for a second. Let's pretend we've just forgotten about rule 1, and let's add up the total for our probabilities anyway. And we have 0.2 and 0.5, which gives us 0.7. Add another 0.7 to that equals 1.4. And then if we add our negative 0.8 in, we still end up with a total of 0.6, which still doesn't equal 1. So both of our rules are not being followed with this distribution. So we know this example absolutely cannot be a probability distribution.